Hey guys, so sad I can't be with you today, but be awesome for the sub. I know you guys are rock stars. What I would like you guys to do is take out lesson 1.2e found in your notebooks. We are going to be taking notes on 1.2e. So anytime when watching this video you get stuck, feel free to leave a comment on YouTube. I'll do my best to check the comments, or you can ask the partner next to you. Also, with these videos, don't forget you can rewind the lesson, you can watch it over again, so on and so forth. When the lesson's over, there's like 2 or 3 videos going to be for this video. When the lesson's over, you can start your homework, so you don't have any. So let's go and start this now if you're ready. So we're going to talk about abstracting the solving process. This is going to be a little weird because what we're going to have instead of normal problems is we're going to have just variables. So let me show you something. Let's look at something that you know. If we have a problem that looks like x plus 6 equals 15, and I want to get x all by itself, what I would do is minus 6 on both sides. This would give me x equals 11. But what if we solve this and instead of these numbers we had variables? For instance, let's say I had x stay the same, and instead of that 6 I had an a, and instead of that 15 I had a b. And I said I want you to get this x all by itself. Well, the process wouldn't change. What I would do is I would minus a on both sides to get x is equal to b minus a. Same idea, guys. We had this problem over here as x plus 6, and what I did was I subtracted 6 on both sides. What we're going to do over here now, we're going to have 0 numbers and just variables, and we're going to still solve for x with that process. So, let's go ahead and look at this. It says solve for the following equations, solving for x. This means in every problem when we look, we're going to try to get x all by itself. So first things first, what I want to do is get x by itself. So the first thing I would do is subtract 4 on both sides. This would give me x equals 6. This is the type of problem that you guys know how to do that you've seen already. But now let's go ahead and take it one step further. Instead of that 4, I replaced it with a b. So I had x plus 4 equals 10. You guys showed me how to solve that by minusing 4 on both sides to get x equals 6. Now, this is what b is saying. Instead of that 4, what we are going to have is the letter b. So, same idea. I have x plus b. Well, how do I get rid of an addition problem? The way I get rid of an addition problem is I subtract b on both sides. This would give me x is equal to 10 minus b. The whole point of this is say get x by itself. I did get x all by itself, so there's nothing more for me to do, and I'm done right there. So x equals 10 minus b. Now what we're going to do is take it one step further, and instead of that 10 I had, I'm going to have a c. So I have x plus b is equal to c, and I want to get this variable x all by itself. So to do that, I'm going to minus b on both sides. So I'm going to get x is equal to c minus b. Remember, c is just an unknown number, b is just an unknown number, and I can't combine them anymore. So this would be my final answer. Now in 5th period, we got a little stuck of like, well, that looks different. It looks a little weird. How am I supposed to solve it anymore? You're actually not supposed to. So this is your final answer. There's nothing more you need to do, and you are done. So let's go and look at this now. We're going to solve the following equations for x. I want you to explain your solving process. So same idea. I have 2 times x. How do I get rid of multiplication? Well, the opposite of multiplication is division. This would give me then x is equal to negative 8. This is a problem that we've seen before. Now let's go ahead and look at one where it's a little new. This is saying a times x is equal to negative 16. I need to get this x all by itself, so now what I need to do is use division. I need to divide because it's a multiplication problem, and I'm trying to get x all by itself, so I'm going to divide both sides by the variable a. These are going to cancel. I'm going to be left with x is equal to negative 16 all over a. There's nothing more you need to do there because x is all by itself, so we're done. All right, so let's go and take it one step further. Now here on letter C, I'm left with 0 numbers, and it's just variables. Remember, the problem I had before was, what was it? 2 2x equals negative 16, and what I did is I divided both sides by 2 to get x by itself. Now the process stays the same, I just don't know any of the numbers now, they're just variables. And it's still the same solving process. So what I'm going to do is divide both sides by a. These are going to cancel because a divided by a is just 1. Remember, this one unknown number divided by the same unknown number is just 1. And 1 times x is just x. And that's going to equal c divided by a. And you can see that these two problems kind of mirror each other on how I solved it. I divided both sides by 2 to get x equals negative 8. Same idea here. I divided both sides by a to get x is equal to c over a. All right, so we're going to skip that one. So let's go ahead and look at this one. If I were to solve this, what I would personally do first is I would subtract 4 on both sides. This would give me 3x is equal to 15. And then what I would do on both sides is divide both sides by 3 to get x is equal to 5. All right. Now that I know that, ax plus b equals c, where b, c represent any number and a doesn't equal 0. And I want to solve for x. So really quickly, I want to copy and paste this really quickly because I want you to see how I solve them side by side. So let me go ahead, edit, copy, oops. I don't even know what that was. All right, so let me go and try this one more time. If I go here, we go to edit, copy, and then we go over here, edit, paste. Okay, so now if I look at this problem, it's the same idea, except instead of 3x plus 4 equals 19, I'm only going to have variables. So in red, I have ax plus b is equal to c. My first step here on the left is I subtracted 4 on both sides. So that's my first step. I'm going to subtract this b on both sides. This will leave me with ax is equal to c minus b. Then I divided both sides by 3 to get x by itself. So I'm going to divide both sides by a to get x all by itself. So x is equal to c minus b all over a. And that's my final answer there. So let's go ahead and look at the next one. Oliver and Sarah both solved the equation 3 times x plus 2 equals 12 for x. Describe their solving process. Now let's look at Oliver. What Oliver did first is he distributed first. He distributed the x and to the 2 to get 3x plus 6. He then subtracted 6 on both sides to get 3x equals 6. Then he divided both sides by 3 to get x is equal to 2. So that's what Oliver did. He distributed first. Now let's go ahead and see what Sarah did first. Sarah did not distribute both sides first. What Sarah did is she divided both sides by 3 first. This left me with x plus 2 equals 4. And then see, she subtracted 2 on both sides to get x is equal to 2. And that was her final answer. So now what we want to do is examining these two equations and see if they both solved them correctly. They both got the same answer. They both followed the operations correctly. So they both did solve it correctly. They were different methods, but they both did it correctly. All right. So now instead, we had 3 parentheses x plus 2 equals 12. So instead of having 3 parentheses x plus 2 equals 12, what we are going to do is we are going to solve this the same method Oliver did, except with variables. What we are going to do, except with numbers, we're just going to have variables. So the first thing that Oliver did, if we remember, is he distributed that 3 to each one of those terms in the inside. P times x is px, plus p times q is pq, and that is going to equal r. I know it's tricky because we're dealing with just variables, but I want you to see it's the same step. If I gave you this problem, most of us would distribute to get 3x plus 6. Well, now what we did was distributed, and we got px plus PQ. That equals R. The next thing that we would want to do if we are trying to solve for x and get x all by itself, we want to get rid of addition and subtraction. I have an addition, so I'm going to subtract this PQ. And whatever I do to one side of the equal sign, I'm going to do it to the other side of the equal sign as well. This is going to give me PX is equal to R minus PQ. Now I cannot combine anything more than this, so I'm left alone with just R minus PQ. Now on this side though, on the left side, I have P times X. To get rid of division, what I'm going to do is, to get rid of multiplication, what I do is divide. So I'm going to divide both sides by P. And those would reduce down here to get a final answer of X is equal to R minus PQ all over P. So that would be my final answer. Like I said, guys, I know it's tricky because we're using just variables, but if I gave you this problem, I want you to see that the process would be exactly the same. The first thing I did is I distributed the P to the X and the Q. First thing I did here is I would distribute the 3 to the X and to the 2. Next, I subtracted PQ on both sides. On this one, I would subtract 6 on both sides. Then, to get X by itself, I divided both sides by P. To get X by itself, I would divide both sides by 3. So it's the same idea. This just shows me the list with just variables. Now let's look at let's look at Sarah. What Sarah did with this problem, 3 parentheses X plus 2 equals 12. What was it? Equals 12. Her first step was she divided both sides by 3 to get X plus 2 is equal to 4. Well, let's go ahead and look at that then. That means my first step is I need to do division 2. I'm going to divide both sides by P to get X plus Q is equal to R over P. Her next step here, which I'm going to do in purple, is I would minus 2 on both sides to get X equals 2. Which means my next step, I need to do subtraction as well. And I would minus Q on both sides to get X is equal to R divided by P minus Q. And the steps should follow exactly the same. Alright, so now what I want you guys to do, we're going to stop the video here. I'd like you now to watch video 2.